On this video, we're going to review parent functions and their graphs and transformations. The first parent function we're going to review is our square root function. And with our square root function, if you do not remember what the basic shape is, you can always do a t-chart, and some of these we'll just have to do a t-chart on because we don't know what it will look like. Start at 0, and so if x is 0, the square root of x is 0. So that means I have the point 0, 0. The next nice point I could use is 1 because the square root of 1 is 1. And then another point we could use would be 4, and the square root of 4 is 2. Now we could use 3, but we try to stay away from graphing decimals if we could help it. The next perfect square we could use would be 9, and that's going to give us 3. So as you see, we have these points, but our curve is really flattening out some. So we're going to have something that looks hopefully like the half of a parabola. And do continue this with an arrow. Make sure you have the arrow there. And so there's going to be our first graph, and that arrow looks absolutely horrid. Let's see if we can do better than that. Okay, so our basic shape by the square root of x will stay the same. Now, hopefully we remember when we add 2 on the outside, that means that we're going to pick up this basic shape we just graphed, and we're going to move it up 2. So that means our x values stay the same, but our y values, we come back and we add 2 to them. So our first point, instead of being at 0, 0, is now at 0, 2. And then our next point, instead of being at 1, 1, it's at 1, and then instead of just 1, we're going to add 2 to it, so we're at 1, 3. And then 4 is going to be at 4, 4, 4. And so we're still going to maintain our same basic shape, it's just we've picked up our graph and moved it. Now the same is true here, except for subtracting on the outside. That means we're going to shift everything down 2. So if I'm shifting everything down 2, instead of being at 0, 0, we're now going to be at 0, negative 2. And instead of being at 1, 1, we're at 1, negative 1. And let's see, if we plug in our 4, we're going to be at 4, 2. And then if we plug in anything else, 9, we would be here. I think I made that too high. That 4 is going to be at 0, not 2. I went way up too many. So we're going to be at 4, 0. That looks a little bit better. And then, of course, if we were at 9, we would be at 1. And so, again, we've still maintained that same basic shape, but we've moved it down. And notice how I am making sure I have both the x and the y values. All right, so now let's look at adding 2 on the inside. We always say that's going to move us back 2. So I know on the inside it looks like we should go forward, but we don't. We are going to go back 2. And a lot of times we're asked, well, why do we move back 2? Well, if we do a t-chart, let's think about how in the world, because we started out with x being 0, so what would I have to plug in here so that I would end up saying f of x of that, it's a nice square root. Well, if I plug in x being negative 2, and then I come over here and I look inside my function, negative 2 plus 2 is 0, and the square root of 0 is 0. Well, how could I get that the next point, which the next point we had was a 1, so we really would need a negative 1. And whenever I plug in the negative 1, the square root of positive 1 is 1. And what about to get 4? Well, in order for us to get 4, we're going to have to plug in something. And let's think about this. I want this whole square root right here. I need to back that up. And if you'll pay attention to your previous x values, notice if I'm backing up amount of 2 each time, well, we could really plug in a 2, couldn't we? Would be where that other value would be. And if I plug in the square root of 2 plus 2 is 2. And so, no, you don't have to generate the the t-chart, but you do need to make sure you have the correct points. Don't just move it over to and sketch it. We need to make sure we have those good points. So here we have it -2, 0. We're at -1, 1. We're at 2, +2. And notice we're still at that same basic shape. And so notice here, if we plugged in 7, x being 7, we would get 1, 2, 3. So again, we've maintained that same basic shape. We still are just moving our points though. Okay, and so here subtracting 2, well, that means we're going to add 2 to all those original x values. So if our original x value here was 0, well, if I add 2, I'm going to have, if I let x be 2, well, then that's going to give me the square root of 0, which is 0. And let's see, if I plug in 3, well, 3 minus 2 is 1, and the square root of 1 is 1. And let's see, plug in 6, well, 6 minus 2 is 4, and the square root of 4 is 2. So again, we have our same basic shape mapped out, and we are maintaining the correct ordered pairs with these. Now, what about multiplying with the negative on the outside? Everyone says, well, that just means that we're going to rotate over the x-axis. And if we need a t-chart, you're still welcome to do a t-chart. Or let's start out at some good values that we know. Well, at 0, I know the square root of 0 is 0. Multiplied by a negative, well, that's still 0. Well, if I plug in 1, work that out, I'm going to get -1. If I plug in 4, the square root of 4 is +2, but multiplied to that negative on the outside is going to give me -2. And even if we plugged in 9, we would get a -3. So again, notice we are maintaining the same shape. We are keeping the correct ordered pairs, and we are sketching this through those ordered pairs. Okay, for our next one, we're going to add some more transformations to this. Let's think about our original t-chart here. And with our original values, remember we had f of x equals the square root of x. And we let x be 0, 1, 4, and 9. We could do that. And notice all of these values we got back. Now, look at what we're going to do to this. Our x values are going to be negative, and then we are going to take all of our y values and multiply those by 2. So let's see if we can figure out what this new t-chart is going to be, and then that'll help us with our transformation. So here's going to be our new. Okay, and so let's see, let's take our original x values. Well, 0 is not going to change a whole lot. Well, 1, well, really, I need to go ahead and let's plug in a -1, don't we? And if I sub in a -1, I get a +1. And so that's going to be multiplied by 2, so I get -1, 2. All right, with our next value, we would need to plug in -4, wouldn't we? And then I'll look up here, -4 times a negative is positive, and then the square root of that's going to give me 2, and 2 times 2 is 4. So notice how we are swapping things. And so with 9, and now let's plug in, we would have to plug in a -9, and that's going to give me a +3 when we take the square root, but remember my y is multiplied by 2, so that's going to give me 6. So now when we come over here and we plot this, we have 0, 0, we have -1 but +2, we have -4 and +4, and then I think the other, can we get -9 on here? -9 and 6. I wish this had gone out just a little bit more. All right, so now here's what's going to be our new graph. So again, we do see that the negative x on the inside did reflect it about the y-axis, and then it also, the 2 on the outside multiplied our y values by 2. If you want to build the T-chart and walk through it, and I suggest you do that until you're able to do these in your head. Don't try doing this in your head if you're no good at it. That would be absolutely crazy. All right, so let's look at our next example. We're going to multiply x by -1 and subtract 2 on the inside. So let's build us a T-chart and see what that does. Okay, so let's go back to our original set of x values, and let's do what we need to in order to get the correct. So I'm going to build us, here's our original x values, and here's our new x values, and then the last one of course would be our f of x values. So let's go through and see. Well, our original x values that we would pick were 0, and then we chose a 1. Originally we chose 4, and then we chose 9, because those are all nice, neat, sweet little numbers that we can take the square root of. Now let's keep in mind what this is telling us. So we need to make x negative, and then we need to subtract 2 from it. So if I make my x negative and then subtract 2 from it, I'm going to have -2. Well, if I make 1 negative and then subtract 2 from it, I get -3. Make 4 negative, subtract 2 from it, -6. And the same with 9, you get -11. Now here's our x values that you plug in to get the new y's. But you should have the same exact y values. Well, let's check and see. Let's look back up here and let me erase some of this gobbledygook that I've written. And let's go plug in and see. Well, if I let x be -2 here, that's going to give me +2 minus 2, and dun, da, 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 0. Plug in -3. Well, if I plug in -3, that's going to make that +3. So that's going to give me 1. Square root of 1 is 1. And as you might have guessed, if we plug in -6, we are going to get +6 minus 2, 4. Square root of 4 is 2. And lastly, we'll get 3. But what's important is to make sure you know where those new x values are. You don't just start sliding and doing all kind of crazy stuff with our graph. So our first point, we have -2, 0. Our next point that we have is -3, +1. So -3, +1. We have -6, +2. And then if we had room, -11, 3. But we know what this shape is going to be, so we can go ahead and sketch it. All right, and we can do the same for the next function, -x plus 2. And let's go ahead and build that T-chart so we see what's actually going on. We can start with our original x values, then we have our new x values, and then lastly we would have our f of x values. So our old values, we had 0, 1, 4, and 9. And now for our new x values, this says make our x negative and add 2. So make 0 negative, it's still 0, add 2, we get 2. And here we're going to make 1 negative and then add 1, or add 2 and get 1. -4 plus 2 is -2. And -9 plus 2 is -7. So there's our x values. We can go back and plug in to make sure we have the right f of x values, and we should. And now let's see, square root of 9 is 3. So now let's plot our points. We have 2, 0, and remember we're using our x1. We have 1, 1, so we have 1, 1. We have 2, -2, 2, and we have -7, 3. 1, 2, 3. So there we go. And so we see that same general shape again, and it has done what we would think it would do. We have reflected about the y-axis, and we have moved left too. But in order for us to actually see that transformation, I highly recommend you do a T-chart. All right, now we're getting to some serious problems here. They're throwing all kinds of gobbledygook at us. But again, let's start with our same basic initial x values, and we will build a new x value, and we will get our new function value. All right, so our original values we had were 0, we had 1, we had 4, and we had 9. All right, so let's see if we can get all of these new stuff going on for us. So for x, we need to make x negative and add 1. So make x negative and add 1. And again, make x negative and then add 1. And the last thing, again, make x negative and add 1. Now let's go plug in and see what our new y values are going to be. Or if you wanted to look at your old y values, you would multiply the old ones by 2, and then you would subtract 3. But from this point, it's really just as easy as to go ahead and plug in your 1 here. So I'm going to have 0. Square root of 0 is 0. 2 times 0 is 0. And then if I subtract 3, I have negative 3. And so for my next value, plug in 0 here. And so I'm going to get 1, square root of 1 is 1, times 2, and then subtract 3, so I have negative 1. Next, plug in negative 3. Well, let's see, inside the radical, that's going to give me 4. Square root of 4 is 2. 2 times 2 is 4, minus 3 is 1. And lastly, let's plug in negative 8. So that's going to give me the square root of 9, which is 3. 2 times 3 is 6. And then 6 minus 3 is 3. So here we have our points. And so let's plot those, and then we can state our domain and range and talk about what happened, what reflections went on. So here, these again are our new points that we're plotting. So we have 1, positive 1, and negative 3. Next we have 0, negative 1. So we have, let's see, our x value. Let's see, did something go awry here? Why in the world? Oh, sorry folks, had a brain fart. So we're going to have x is 0. And let's see, our y value is negative 1. I was thinking this was flipped the other way. Losing my marbles. Sorry folks. So now negative 3, positive 1, and then let's see, negative 8. So all the way back here up 1, 2, 3. And so there once more is our general shape. And let's take the domain and range of this. They wanted to know, well, what in the world would be the domain of this particular function? Well, domain is how far left, which again looks like negative infinity, all the way to how far right. Well, how far right did we go? We went all the way to positive 1, didn't we? And then our range for this, again, that's how far below the x-axis. Well, how far below the x-axis was to negative 3. And then how far above would be positive infinity. And we also needed to state our changes that were made to our basic graph. And that's really here, I would let my t-chart show that. These are the changes. And if we need to write that out, we can. It might be a good idea. So here, what changes happen? Well, the first change that happened, we reflected about the y-axis. Reflected about y-axis. So that's the first thing that happened. Then we also shifted, looks like left 1, didn't we? Shifted left 1. What else did we do? Well, we multiplied by 2. And what does that multiplying by 2 do? It really gives us a condensing, but we're not going to be really worried about that. Now we do need to make sure that we did move down 3. Okay, and for the next one, let's go ahead and look at what's going to happen here. And let's see if we can go ahead and just state, well, what's going to happen with this? Well, the first thing that's going to happen is we need to reflect about the x-axis, aren't we? So we will reflect about the x-axis. Let's see, what else will need to happen with this? So we will need to shift right. So we are going to shift right 1, and then we're going to shift up 3. Okay, so let's see if we can figure out what our new x and y values are going to be. So if we refer back to our old x values, so let's scurry back over and grab those homeboys here. All right, and so we have x of 0, and we started out with 0, 1, 4, and 9. But now we want to know, well, what are our new x values? And with those new x values, what's going to be our new function value? Well, we need to think about what's going on under the radical. So to maintain those nice, neat, perfect square values, under here I'm going to be subtracting 1. So really, whatever I put under x sub 1, our new x value, I need to add 1 to offset that subtraction. So our 0 now becomes a 1. And our 1 actually becomes a 2, our 4 becomes a 5, and our 9 becomes a 10. Now let's see why I'm saying that. It's like, all right, you're doing more correct today than normal. Well, the reason why is if I take this 1 and I plug in, I get 1 minus 1, which is 0, and then negative 0, still 0, plus 3 is 3. So it still works out nice and neat here. And do remember, you were told that if there's a negative inside the function, you're really shifting to the right, which implies that I'm adding 1 to each of those x values. Now if I add 1 to 2, well, let's plug in 2, sorry. 2 minus 1 is 1. Square root of 1 is negative 1 with our negative on the outside, so that's going to generate a 2. If we plug in 5, we're going to get a 1, and if we plug in a 10, a big O 10, let's see, what's that going to give us? It's going to give us 0. So let's see what's happened to our function. And remember, we're plotting those two. So I'm at 1, positive 3, and then I'm at 2, 2. Okay, this is looking weird. I'm at 5, 1. And then if I was at 10, I would be at a 0. So notice what this thing is doing. There's all kinds of things. This graph really got jiggy with it here. So let's talk about what's the domain and what is the range for this one. So the domain here, if we write the domain, again, that's how far left did I go, which how far left did I go? I went as far left as 1, and I'm going all the way to positive infinity. The range for this, how far below the x-axis? Well, if I extend this on out, my y values would be approaching negative infinity. Notice how they are decreasing in value. And that, let's see, how far above? The highest value we got was a 3. And then we've already stated all the different shifts for this. Right, let's move on to some other parent functions that you learned from Algebra 2. The graph of x squared, and that's such an important graph for you to remember. The graph of x squared, remember we did start at 0, 0 with x squared. And let's see, you had 1, 1, right? And let's see, then over at 2, you would go up to 4, wouldn't you? 4, and of course that's mirrored over here, 1, 2. And so here's your basic parabola shape. And all those transformations we just went through would be the same. All right, with the absolute value, remember that did make a V shape. It was at 0, 0 and 1, 1, negative 1, 1. Now do be careful with this. We do want to maintain that V shape. So do your best to make sure this does come to a short or a sharp point here is important, and we'll see the differences and why we want a sharp point and a curved point later on. With a cubed root function, that was really like a tangent function on its side. So a cube root function, you had something that looked more like this, and that's okay. We're doing this just a rough sketch here. And then cubic, that really looked a lot like the tangent function, did something like this. All right, so there's some good reviews on those. And again, using our transformations, and let's just see if we can figure out with our transformations, let's see what, and all right, so let's talk about what's going to happen here. We're going to have to take our original and we're going to move it left 2 and then down 3. So let's go ahead and just do a rough sketch of this. So here we're going to start at 0, 0. We're going to go back 2 and then down 1, 2, 3. And then we're just going to do a nice little sketch here. And notice I'm omitting all of the T-charts. We'll get to those T-charts if we need it, but it's really there to help us see what is going on with our function. Here again, well, let's see. Let's think about the original parent function starts at 0, 0. Well, we are going to go left 1 and up 4. So left 1, up 1, 2, 3, 4. And then we're going to need to flip this over. So we have something that will look like this. Right? And continuing on, let's see. We have, ooh, this one's going to look horrible. Let's see what we can do with that one. Well, we have our regular cube root. So let's over here to the side think, well, I know what my cube root looks like. My cube root looks something like this. And I'm there at 0, 0. Well, the negative, well, that's going to make that negative of it. Well, that's going to flip that bad boy around. So whatever we had, let's say, if we plug in here the negative, well, x being negative is going to reflect it about the y, isn't it? So now it's going to look something like this. Well, that's weird. And then we're going to have to, we add 2, which means I'm going to move that point back 2, so 1, 2, and then down 3. 1, 2, 3. Wow. So now we have something that looks, it's going to go off that direction and then come up and go this direction. Very strange. All right, and then here with our cubic, same idea. Let's start out with just what that basic cubic function looks like, with something like this. All right, and so when we make x negative, we are reflecting about the y. So now we've got some nonsense like this. All right, and so we need to take that 0, 0 point, and I need to move it to the right one, nope, left 4. 1, 2, 3, 4, and then up 1, and then I'm going to maintain that same shape. So it's going to come through here and look something like this. All right, let's move on. All right, so here we're going to be back to working with our ordered pairs and seeing how those go as far as our transformations. And notice they've given us a table of values of our original values are here. And then they want us to come down here and actually fill in the ordered pairs and what's going on with this. So we state the shapes or the shifts or reflections. And let's see what's going to be the new point. So let's see. Let's start with the coordinates of f. They give us the ordered pair -3, 5. So the x coordinate, what's going to happen to our x coordinate? Well, it looks like the x coordinate is going to stay the same. But what about the y coordinate? Well, the y coordinate, which is going to be right here, it's 5. Well, that y coordinate, we're going to make that negative, and then we've got to add 2 to it. So if I make 5 negative, that's negative 5, plus 2 is going to give me negative 3. So my new ordered pair is negative 3, negative 3. So the same is true with negative 1, 1. Well, the negative 1, the x-coordinate, stays the same. The y-coordinate of this, well, the y-coordinate, we need to change the sign and add 2. So we're going to make 1 negative 1 and then add 2 to it, gives us positive 1. So we have the ordered pair negative 1, 1. And again, our x value stays the same. Our y value, we need to change the sign and add 2. So that's 6. So my new ordered pair is 1, 6. X again stays the same. We change our y value and add 2. So I have 3, 1. And then the same is true with the last one. 5 stays the same. 2 becomes negative and we add 2 to it. So my ordered pair is 5, 0. So what shifts are taking place here? Well, if here negative f of x, that means we are reflected about the x. So we reflect about the x-axis. And then we move up 2. All right. Okay, so now let's see what goes on with this one. And now they've put all kinds of crazy stuff with it. So let's go ahead and see if we can figure out, well, what's going on with the h? For our h values to line up, remember this means that I move left 2, isn't it? If it's on the inside, that's left 2. So that means all my x values, I need to subtract 2. So let's see, we've got to subtract 2. So that means that negative 3 minus 2, that's going to be negative 5. And let's see, our y values, we need to multiply by 3 and then subtract 3. So if I multiply by 3, I get 15. 15 minus 3 is 12. So my new ordered pair is negative 5, 12. All right, so again, for the next one with our x value, we subtract 2. So that's going to give me negative 3. And then our y value, we multiply by 3 and then subtract 3. So our new ordered pair is negative 3, 0. The same is true for the next. So 1 minus 2 is negative 1. And then with negative 4, so I'm going to multiply negative 4 by 3. That's negative 12. Negative 12 minus 3 is negative 15. So here we have negative 1, negative 15. 3, 1. So again, we need to subtract 2 from 3. And then for our 1, we multiply by 3 and then subtract 3. So my ordered pair is 1, 0. And then finally with 5, 2, same idea. We need to subtract 2. And then with our 2, we're going to multiply by 3, which gives me 6. 6 minus 3 is 3. So our ordered pair is 3, 3. And again, our transformations, we went left 2, we went down 3, and then we had a, well, depending on how you want to look at it, we could have a horizontal stretch, a vertical shrink of 3. So why don't we just call it a dilation of 3? All right. All right, we're almost finished. The next thing we need to review would be our piecewise functions. And we know what our basic shape should look like here. We know we have a parabola, and that parabola is only going to exist from 1 to 4. And I always suggest, again, a T-chart for this, but we're just looking from 1 to 4, so it might be a good idea to always start with, let's see, we've got x and g of x And I know this is not equal to -1, so that's why we are going to use it, but we're just going to do an open circle there. So if I plug in -1 for x, that's going to give me -3 squared, which is 9. 9 minus 3 is 6. So my first point here is going to be -1, +6, but it's going to be an open circle. Okay, so that's the endpoint there. And let's check our other endpoint of 4. Now 4 will be a closed circle, so when we plug in, we have 4 minus 2, which is 2. 2 squared, 4. 4 minus 3 is 1. So here we have 4, 1, and it is a closed circle. Now to get that vertex, we can look here and here, and remember our transformations. This is a normal good old parabola. There's our Walmart parabola there. And so we need to move right 2 and down 3. So from 0, 0, we're going to move right 2, down 3, and now we have our vertex, so we're able to connect our dots. And again, try to make that rounded, and I assure you it has a reason why we need to distinguish between a rounded end and a sharp end. All right, now for our next values here, 2/3 x plus 2, we know that's a line, but our values for that line need to start with 4. So again, I'm going to plug in 4, but it's going to have to be an open circle. So let's plug in 4. Oh goodness, this is going to give us some ugly fraction mess. We'll work with it. So 4 times 2/3, that's going to give me, let's see, I'm out of room, aren't I? So that's going to give me 8/3 plus 2. Well, 2 is the same thing as 6/3. That's 14/3. Who the heck knows where that's at? So let's change it to a mixed number. So 3 goes into 14 4 times with 2 left over, so 4 2/3. So let's go over 4 2/3. So 4 2/3. Oh my goodness. So 4, and then we're going to go up 4 2/3, a little bit above that, make our open circle. And now let's see, what would be another point we could plug in? Looks like 6 would be a good one to plug in. Let's see, 2/3 times 6, that's probably going to be 4, isn't it? 4 plus 2 is 6. So we have the point 6 and then 6. That's going to be a close point. And we can count off our slope from here. We rise 2, run 3. All right, so here's some good points. And that needs to be a close point, but for some reason it's not working out for me. Get back in there. All right. And so again, now this one's going to have an arrow on the end because that continues. The other one didn't. All right, so there's our nice little piecewise function. All right, and let's see if we can't do number 2. Let's try that one. So again, let's start here. X has to be less than -1. So, of course, we're going to plug in -1. We're going to be rebellious and say, oh, yeah, we can plug in -1. So if we plug in -1 here, we're going to get 1 plus 1, which is 2. So I know this top part here is going to start at -1. -1, +2, open circle. All right, and it's a V. We also can figure out where our next point should be. So our vertex means +2. Oh, we're going to have to shift to the right, or to the left 2. So from 0, 0, we shift left 2 and up 1. So there's going to be our vertex. And so we're going to go from here to here. But then over on this other side, this continues on forever and ever, amen. So there it is. And then a lot of times people get really confused right here. This is just an ordered pair. That is the same thing. This is just fancy notation for -1, 3. That's all it means. So we have a for sure point on this graph at -1, +3. That's all that means. And then moving on to the other, we have a line. X is bigger than -1, so let's go ahead and start out at -1. Always be rebellious there. Start with -1, If we plug in -1, well, that's going to give us +1/2 plus 5. That's going to give us 5.5, right? So we're going to be, x was -1, and then y was 5.5, and it's going to be an open circle. And let's see, we know our y-intercept is +5. And from that, we can count off our slope. So we need to move down 1 and run 2. Down 1, run 2. And so, voila, here's the other piece of our piecewise function. All right.